Hello everyone, I'm Suhasini. Welcome back to my channel Learn with Suhasini Shinde. Okay, the next topic is we will study what dielectric materials are, right? Now these dielectric materials are the non-conducting materials. They do not conduct any electricity, but they can transfer the electrical effects, right? For example, what are the dielectric materials? It can be glass, it can be water, it can be air, it can be vacuum, right? These are all the dielectric materials, right? This dielectric material has again further divided into two categories. One is polar dielectric material and another is non-polar dielectric material. Right, now let us understand what do you mean by the polar dielectric material and the non-polar dielectric materials. Right, now before that, now I said you that these dielectric do not conduct electricity, right? But when they are kept in the effect of electric field, they start conducting, right? They start conducting only under the effect of electric field. When the dielectric medium is kept under the effect of electric field, they start conducting, right, the electricity, and hence how they conduct differently. Now the polar molecules or the polar material behave separately and the non-polar material behaves separately. How the polar and the non-polar material will behave when we put them into the electric field will be understood now. Right, now for example, say you have two sections, right? There are two substances under dielectric material. One is non-polar and another is polar, right? The name itself says non-polar. Polar means polarities. It is non-polar, then it has no polarity. It has a molecule. Now say for example that dielectric material has a molecule into it, that particular molecule in which the positive and the negative charge share the same center, right? The center of the positive and the negative is similar, that is only one, and hence there is no distance between the positive and the negative charge. These type of the materials are called as non-polar dielectric materials. Do you understand? What do you mean by dipole? For example, if you consider, what do you mean by dipole? Dipole are the two and equal opposite charges with a very small distance between them. That particular arrangement we call it as dipole. So how do you arrange it, or how do the dipole is shown? This is positive, this is negative with a very small distance between them, that is 2a, right? This arrangement is called as dipole, right? Two equal and opposite charges with a very small distance between them is called as dipole. That you have learned in very last classes, right? Now what this particular non-polar molecule says here is the dipole of this particular non-molecule will be equal to 0. Why it is equal to 0? Why? Because the dipole is not produced at all here, right? The center of the positive charge and the negative charge remain same, and hence there is no distance between the positive and negative charge. It is coinciding on one another. It means they are so near that it resembles like it had coincide, right? And hence there is no polarity formed here, and hence there is no distance between positive and negative, and this particular molecule you call it as a non-polar molecule, right? And hence if at all this is a substance and which has molecules into it, now it is very clearly understood from this sections, that is the positive and negative share a similar center, right? The center is one for both positive and negative, and hence there is no, they resemble, it seems like they are coinciding with each other, they are coincide each other, right? Whenever you have a dipole, then there is this distance between positive and negative, right? But there is no distance between positive and negative. They are almost very nearer and very close, right, to each other, and hence they do not share any different centers, and there 2a, the distance between the positive and negative is equal to 0, and hence there is no dipole, right? Such materials are called as non-polar. Now say for example this is a dielectric substance, right, which has so many molecules into it. How these molecules are? The molecules are arranged such that they have no polarities into it. Hence there is no dipole into this particular region. Now what you do, you keep or you get this particular, and hence electric field at this particular point is equal to 0. Why? Because we haven't applied any electric field. Now what you do is apply electric field for this particular dielectric material, then what happens? It starts conducting. How does it conduct? Let us understand. Now there is no electric field here, right? There is no electric field. Now for this particular material you apply electric field. After applying electric field, what happens is, right, you have these molecules here, right? After applying electric field, you have applied electric field for this material, right? Then what happens? Now these starts moving apart. The positive and the negative charges in the molecule start moving apart. The positive move in the direction of electric field and negative move opposite to it. Due to this, what happens? There is a separation of positive and negative charges takes place in this molecule. Positive move in this direction and negative in the opposite. So now the arrangement of the positive and negative charges is such that positive charges are all on the right hand side, negative charges are all on the left hand side. Why positive are arranged in the right hand side? They try to move in a direction of electric field. Which direction the electric field is moving? It is moving like this, right? And hence all the positive charges are aligned in this particular manner and the negative in the very opposite. Due to this, what happens after the electric field is applied for the dielectric material? There is a creation of the dipoles. The dipoles are created now. There is small distance between the dipole now. There is a distance between the dipole, right? And the center of the both the positive and the negative charge is departed now. They have a different centers, right? And hence the production of the dipole under the effect of the electric field is called as polarization, right? This is also a very important question. They can ask you, what is the polarization? Polarization is a process of production of the dipoles in the dielectric material under the action of electric field. If at all you have applied no electric field, then there would no dipole production of dipole, and if there is no dipole production, then there is no polarization possible. Then what does this mean? For dielectric material to conduct, there require polarization. When if at all the polarization has required, then definitely there should be electric field, right? Without electric field there is no polarization, and if the dielectric material is not polarized, then it doesn't conduct, right? Now example, you have applied the electric field and all the charges are separated and the dipole is created, right? Now what happens here is all the charges that are present here will get cancelled out and there forms a separate positive layer on the right hand side and forms negative layer on the left hand side, and all the internal charges get cancelled out each other, and hence this particular surface will look like it has been created a positive layer on the right hand side and the negative layer on the left hand side due to the polarization effect, right? Now there exists two electric field. One electric field which you have applied in this direction, right? Now another electric field is generated due to the dipole here. Now this is dipole, this is nothing but dipole again, a positive and the negative equal in amount of magnitude and with a small separation of a distance of 2a. The dipole is created, right? The dipole is created such that the internal charges are nullified and we have only the layered charges, that is positive layer on the right hand side and the negative layer on the left hand side, right? Whenever there is a charge, there exists some electric field lines, right? How does the electric field lines are? They are from positive to negative, right? They are away from positive and they are moving towards negative, right? Now if at all you can understand here properly, electric field that is applied for this particular material is in this direction, is in this direction. Say for example you take it as E naught, right? Electric field that is applied for this particular material is in this direction, which is represented as E naught. Now you have another electric field generated due to this dipole, that is from the positive to negative, and this is moving in opposite direction, right? In this direction, say for example because of the dipole, that is E, right? Now if at all you want to find out what is the net electric field on the dielectric material, then how do you do? The net electric field on this particular medium will be a differentiation of both electric field due to the normal that is applied and also the electric field that is created by the dipole, that is E naught minus EP, right? Then you get some electric field here, right? Now at this particular point, dipole is not equal to 0 and you get some electric field which is also not equal to 0. Did you understand? Right? The dielectric materials are the substances which do not conduct any electricity, but when they are kept under the action of electric field, the polarities are formed. That is, the dipole are formed. The process of production of the dipole is called as polarization. Once the dielectric is polarized, it starts conducting, and it also generates another electric field due to the dipole. One because of the electric field that is given to the substance, and another which is generated by itself through the dipole, that is EP, right? And the net electric field of that particular substance can be defined as E net is equal to E naught, that is applied electric field, minus the electric field that is generated by the dipoles, right? And hence this is the net electric field. At this particular point, the dipole moment is not equal to 0. Why it is not equal to? Initially there was no dipole, and hence the dipole moment was 0, and there was no electric field applied. Electric field was 0. But at this particular point, the polarity is created. Now there is polarity created, and they have distance between them. The polarity is not, the dipole is not equal to 0, and the electric field is not equal to 0. This was all about the non-polar dielectric material. Did you understand? Right? Next one is polar molecule, or you can call it as polar dielectric material. In polar dielectric material, you have dipoles, but they are randomly arranged into the substance such that the net polarity or the net dipole moment of the system again remains 0. Initially, what happened in the non-polar molecule? There were no dipoles, but still there were no dipoles, and hence the dipole moment was equal to 0. But in the polar molecule, you have dipole, but the all the molecules are arranged such that they are randomly arranged such that the net dipole moment of again the system equal to 0, and hence the dipole moment will be equal to 0, and hence there is no electric field initially, so electric field will be equal to 0. What type of materials are called as this polar molecules or polar dielectric material? The material which has the dielectric or the dipoles. The material which has the dipoles present with some distance between them, and the positive and the negative charge has a different centers to share, that type of the molecules are called as a polar molecule. Now see, if at all you can understand, the molecule which was arranged in non-polar, see, they only have one center, right? And there is no distance between positive and negative. But in the polar molecules, they have the charges are separated with some distance, and all are dipoles here. But these dipoles are arranged very random manner such that again the dipole moment is equal to 0. And electric field is not applied, and it is equal to 0. Now what you do at this particular point, this is not conducting now. When this dielectric material kept under action of electric field, it starts to conduct. How it conducts, let us understand. Now this is a material. Now you apply electric field to it, right? What happens? This arrangement will properly shift their position in this manner, right? After application of electric field, again the positive and negative charges are aligned systematically in this direction, right? Initially the position of this all molecules were randomly arranged. After the application of electric field, the molecules arranged such that all the positive are moving in the direction of electric field, and all the negative are separated. Now there is a proper alignment of the electric dipole, due to again which what happens is the central all charges get cancelled out, and it forms a separate layer of positive and negative. Positive at right hand side and negative at left hand side, right? And all the central elements or all the central charges get cancelled out, and hence you get a material with two layered, right side positive and left side negative. Again the generation of the electric field takes place. One electric field was because what we have provided to this particular material, right? Again the another current that is generated from positive to negative, that is electric current due to polarization, and you have another current, that is E naught. What is the net electric field of this particular thing? That is net electric field will be equal to E naught minus EP, right? Now initially this polar substance was not conducting, but when it is kept in the action of electric field, it started conducting with the generation of another additional current into it due to the dipole, right? That is EP. The net overall electric field of this particular material is given by E net is equal to E naught minus EP. Now what do you think how the polarization and the electric field that are related? If you increase electric field, then it increases polarization. Do you think it increases polarization? Yes. What do you mean by dipole moment? That is net dipole moment. How it is represented? It is represented as Q dot 2a, right? Q is the magnitude of any charge and 2a is the distance, right? When you increase electric field, the dipole moment also increases. When you start increasing the electric field in a molecule or in a substance, the separation of the Q and this Q plus Q and minus Q also start increasing, right? The 2a, the distance between the positive and negative charges increasing. When the distance between the dipole increases, the polarization also increases, right? Electric field is directly proportional to polarization. Greater the electric field, greater is the polarization. How greater is the polarization? By increasing the dipole distance, that is distance between positive Q and minus Q, the net dipole increases. When net dipole increases, the polarization also increases, right? And how do you define polarization? Polarization can be defined as the net dipole moment that is produced to that of the volume, right? Now this is a definition of polarization. More the amount of the dipole that is produced to that of the volume, the polarization increases. And how the polarization and the electric field are both related? They are related directly. More the electric field that is provided to any particular that is dielectric material, the more the dipoles are formed. More again you increase the electric field, the distance between the dipole is again increased, and hence due to which what happens, the polarization increases and the dipole moment also increases, right? And hence we can write P is directly proportional to E. This proportionality constant is removed and which is equated to this particular constant. It is called chi is equal to E, right? Okay, now this is the equation for polarization. P is equal to polarization. This notation stands for chi. E is equal to electric field. This chi is called as electrical susceptibility, right? What is this chi called? It is electrical susceptibility, right? And this is what the equation is, right? Now why these dielectric materials are used, right? The dielectric materials are used to reduce the effect of electric field. Wherever you want to reduce the electric field, right, you introduce dielectric into it, right? Is this clear, everyone? Now this, by this equation you can clearly understand the susceptibility, electrical susceptibility of different materials is different, and hence if the susceptibility increases, the polarization increases, right? It is directly proportional, right? The susceptibility of glass will be different, air will be different, vacuum will be different, right? Water will be different. As the term susceptibility is, you get the polarization. More the effect of the electrical susceptibility of that particular material, more will be the polarization, right? Now this is all about today's class. In the very next class, we'll start with the capacitance, right? In the capacitance, we have a dielectric that is produced inside the two parallel plate capacitor. You know how capacitors are introduced or how the capacitors are denoted. Now these are the capacitor plate, and in between you have a dielectric material, right? Now this dielectric material and the behavior and what the types of dielectric, the internal dielectric is present is being all taught here, right? Initially the dielectric material do not conduct, but when they put into some electric field, they start conducting due to the effect of polarization. Understood? This is very clear up to this point. Understandable up to this point, right? In the very next class, we'll start with the capacitors, right? This is what all about today's class. In the very next class, we'll start with the capacitors and followed by all the other topics, right? If you like my channel and if you like the way I teach, you please do subscribe to my channel. Share the link with the friends and families. Your one share can really help one particular student if at all he genuinely wants to understand the things, right? A playlist for the very first chapter has been created. If at all you want to know or to study the entire electric charges and field subject, or the topic, you can go to the playlist and you have 10 different videos of that particular chapter. You can play it all, and I assure you that you will be understanding it completely, right? You please do support, and if any suggestion from your side and how the videos are reaching out for you people, if at all you could comment or suggest me something in the suggestion or drop a message in the comment box, then I'll be very grateful for all you people, right? And the notes for this particular chapter will be found into the description box, right? I have a handwritten notes for this, all the things, right? Exactly what the things that is being explained in the classroom, that is in this particular videos, will be followed that by the handwritten notes, right? You can please go to my website, download the notes, and then after looking into the videos, if at all you study the similar lines, then it will be very helpful and very easy, and it consumes very less time of yours, so that you can dedicate your other time for different subjects also. Let me know if at all any changes or any improvements has to be done, and keep visiting my channel and do support, and thank you so much.